Hello and welcome to the TTI Distribution Download, the podcast where we talk about all things happening in the world of electronic components with the specialists of TTI. And now, your host for the TTI Distribution Download, Paula Renfrow.
Thanks, Jim. Hey, everybody, and thanks for plugging into the TTI Distribution Download. This episode, we're welcoming our good friend and Senior Technical Applications Manager at Nexperia, Tom Wolf. Welcome, Tom.
Hello, Paula. Hello, everybody.
And returning to the booth today, TTI Director of Technical Marketing, Pat Denton. Thanks, as always, for joining in on the conversation, Pat.
Thanks, Paula. Appreciate it.
Tom, let's start off. Tell us a little bit about your career journey and the work that you do at Nexperia.
At Nexperia, I'm a Senior Field Application Engineer, and that is a derivation from the design work that I did early in my career doing designs for IBM and General Electric. Since then, though, I've been a Field Application Engineer on a wide variety of different products. Worked for Intel, AMD, NEC, NXP, the mother company of Nexperia, on just a wide variety of different devices. So I enjoy solving customers' problems by looking at the whole different new types of technologies that are out there and helping customers to design them in.
Well, we have a series where we talk to our guys in transportation about electric vehicles, and something that we touch on every time is battery life. And I understand this is a different application, but it is a battery life being just a hot topic, right? Everywhere. Today, we're discussing Nexperia's Battery Life Booster. So, as the name implies, these are components designed to extend the life and peak output of a typical lithium coin cell battery. Pat, why and where is this technology valuable?
Sure. Extending a coin cell battery's working life significantly reduces battery waste in low-power IoT and other portable applications, while making coin cells a viable power source for applications which could previously only operate from AA or AAA type batteries. And Tom, as the expert on the subject, help us understand the issues with coin cell batteries.
Okay, well, coin cells are used everywhere nowadays. You've probably handled some of them not too recently, as a matter of fact. So they show up in automotive applications. That's the coin cell. Looks like the size of a coin. Fits in your key fob for starting your car remotely. They're also used in things like tire pressure monitors that relays the information back to your main dashboard. But it's not just automotive. Coin cells are used all over the place. They're in all sorts of consumer electronics, smart tags, the little tag you put in your luggage, so when the airline loses your luggage, you can hope to find it again and discover that probably your luggage had a more interesting vacation than you did. They're also
I love that application, right?
And they also show up in other sorts of applications, a lot of health and fitnesses. They may be in a monitor that you put in your shoe if you're a runner, if you're an athlete. They might be in a heart rate monitor, a glucose monitor. So there's all sorts of applications for them. They're such a nice, neat size as you can kind of hide the battery away, and we'll talk about that later as well, too. But they're very convenient for those types of applications where I need a fair amount of power, but I don't have much room for them. They also show up in remote controls, not the big ones, because there's plenty of room for a AA or AAA in those, but in the little small remotes that are specialized for like electric candles and sorts of things like that. But believe it or not, the biggest application for them is not the consumer. It's probably something that you wouldn't see on a regular basis. It's the industrial and the sensoring marketplace. They show up in things like asset tracking. So they're kind of like your luggage finding tag, but they'll go into a shipment of fish, which is being shipped across the country because you want to know if that fish stays frozen all the way across the country. So all sorts of asset tracking for things like that, for building automation, temperature sensors, fire monitors, just general security. You peel and stick the sensor on the window or somewhere around the factory that can then relay information back to a central security facility. Or e-meters, an e-meter or gas meter on the side of your house. So coin cells are used everywhere in very, very large quantities.
Okay, so what's the issue with these applications?
The issue with those applications that I specifically mentioned is that is not what coin cells were originally designed for. The coin cells, and this is where we're going to date ourselves here, is that coin cells were originally designed as a derivative of watch cell batteries. Remember watches that used to have hands on them that, have not the smart ones, the dumb watches from the past. And then along the way, they started to be used in electronics. And one of the most popular ones was using the CR2032 as the battery backup for the time of day clock in the original IBM PC, which stayed around for a long period of time. Now, what is interesting about those applications then to what we use them for today is that those applications in the past were a low amount of current for a long period of time. A watch doesn't use much electricity when it's running, and so you only had to change the battery every 6 months or a year, or large amounts of time, or the battery backup on it. Today's applications, though, are being used in applications which are different than that. They're called pulse mode applications. For example, your key fob, when you push it, it doesn't do anything most of the time, and then you push the unlock or remote start your car, and it sends out a huge amount of power by RF or Bluetooth or Wi-Fi or some sort of radio communication, to your car, which is parked across the parking lot at Walmart. So it uses a lot of power in a very short period of time. And that's what the batteries were never designed for in the first place. It damages them and ruins the life.
Are there any other technical issues with the coin cells?
And so that really is it. Using these batteries in a method that they were not designed for, it actually changes the chemistry of the battery inside, and it destroys the lifetime. You're physically getting rid of it. Now, there's a lot of advantages in these batteries. As I said, they're very small. You've seen them before, so they're very convenient. You can design them into places. You can make a remote controller, a product which is not much thicker than a credit card, so they're really useful. And they're very, very high energy density. You can get more power in that little coin than you can get in a much larger rechargeable, or sometimes even double or triple A batteries. There's a lot of power in a very little pack like that. And because we use so many of them, they're low cost. You start buying them in quantity, and you're talking, a coin to buy these things. That's the good side. Like I said, the bad side of them, though, is that they have high internal resistance on them. It's on the order of like 10 to 100 ohms. So what that means is when you draw a lot of current out of that battery, you have to worry about the voltage drop through the resistor, which is inside the battery in the first place, which means you try to draw a lot of current, and instead of it being at 3 volts, it drops way off. You're losing energy in the resistance of the battery. It doesn't like high pulse currents. It also depletes the electrolytes. So if you keep hitting that battery in an application, a pulse application, like a radio transmitter or an alarm sensor or something like that, you're going to chemically destroy that battery much quicker than it should have been.
What about environmental issues? What are the environmental issues with coin cells?
Well, those two things sort of just stack up on it then. Because I'm shortening the life on the battery, I have to change it way more often. Somebody did a study on it. And again, we only see the batteries that go into our consumer products. I'm always changing batteries and key fobs in my family, but it's in the industrial market where they use them up. And it appears right now is that the number of batteries which are being used up is around 70 to 80 million per day.
Wow.
It's a mind-boggling number of batteries which are being thrown away. And, they've got lithium and metal and stuff in them. You don't really want them in a landfill in particular. So we wanted to come up with a way of greatly reducing just the raw number of batteries which were used instead, so to get rid of those and save the environment and save you some money at the same time as well, too.
Right. So what's the real cost of using these cells?
Now, this is where it gets interesting. If you're just a consumer and you're saying, hey, I have to go down to Walmart and buy a new battery to replace the one in my key fob, that's not a huge amount of cost. Batteries aren't that expensive for it, so you can get them done. The problem is when you use them in an industrial environment, which, like I said, is where most of them are used. Now it is not you, a consumer, changing the battery. You've got to call a technician in. So suppose you have hundreds or thousands of these scattered around your factory, and you know that they're going to burn out in a month or 2 months or whatever they are. So you've got to send a technician out to fix those. So it's not the cost of the battery that's significant. It is the cost of the maintenance to change that battery. For that guy to drive his truck out to the factory, get on a ladder, go up in the ceiling, change the batteries out inside them. Now you're talking a very significant cost every time you change the batteries. And it's not just that cost of replacing them. There's a cost of lost opportunity as well, too. All these batteries don't last the same amount of time. So you kind of have to guess, I should replace all of them in 3 months, because you don't want to go out and replace them one at a time. That's a lot of miles. Instead, you'd like to say, hey, I want to know when all of them are dead at the same time, and I'll replace them all at the same time. But if they die before that, that means that your fire sensor may not be working because that node, its battery died on it already. That's really why we go through so many batteries in that environment, is everybody tends to swap them out way before they're needed, just to make sure one of them never goes dead in particular. It also limits the number of applications that you can use them for. You may want to transmit the temperature or something once an hour. Well, gee, it'd be nice if you could do it once a minute to get more data. but the battery doesn't have the life on it. So some features you can't do because the battery just doesn't have enough life in it in the first place. So what you end up with is particularly in the industrial environment, it's very expensive to replace them from a service point of view. It's expensive from an environmental point of view because you're throwing all these things into a landfill someplace. It can be expensive because you are open to something bad happening because your sensor battery left and you didn't know that the building caught on fire, for example. So it's a lot of work with these batteries. They're very useful for what they do, but when they're not doing it, they can be quite costly. And that's really what we're trying to save.
Well, Tom, you've given us a lot to think about already. I'm going to suggest that we take a breath here with this episode, and then next episode we'll come back and talk about answers. Good?
Sounds good.
Sounds good.
Great. And thank you to our listeners for plugging in today. If you learned something, you'll definitely want to plug into our next episode where Tom and Pat will talk about how Nexperia battery life booster technology can improve your coin cell battery applications.
That's it for this episode of the TTI Distribution Download. For more information on any of the topics you heard about today, reach out to your nearby TTI branch at 1-800-CALL-TTI or visit us online at tti.com.